All right. So we're on sine diagrams, and we've got our first one here. We're going to draw the sine diagrams under the Cartesian planes that we've got. So the important information is on the x-axis. What we are going to do is we're going to draw a horizontal line underneath the graph that represents the x-axis. And we're going to draw out what we call the roots. Okay, roots, x-intercepts, or more rarely, you'll hear them called solutions. For our purposes, all of these mean the same thing, okay? So the root of this line, okay, the point where it crosses the x-axis is -3, right? So we're going to draw that on our axes here, on our sine diagram. We have the important point is -3. And now, all we're doing in the sine diagram is we're indicating, is the graph above the x-axis or below the x-axis? So, to the left of -3, we can see the graph is above the x-axis. So that means we say the y values are positive. And then to the right of -3, we can see it's below the x-axis, so our values are negative. Okay, this is a sine diagram. All right, let's have a look at B. In B, we have a parabola. It looks like this. We have -4 and +2. So if we're going to draw a sine diagram, we don't need any y-intercepts or anything like that. We're just interested in the x-intercepts. So we'll make them correspond accordingly. We have -4 and 2. We can see to the left of -4, the y values are negative. In between -4 and 2, they are positive. And after 2, they are negative. All right, so we're getting the hang of it. We have 3 and 5. Okay, so it's a horizontal line. We have arrows going both ways. We have -3 and 5 are our x-intercepts. Now, if we're looking at this one, we can see it touches at that point, but it doesn't go below. So what's going on is it's positive to the left of -3. It's above the x-axis. Okay, it's positive there. It's also positive between -3 and +5. So even though it doesn't change, we still need to indicate this on the graph, on the sine diagram, because it's one of the solutions, one of the relevant solutions. And then to the right of -5, it goes below. So we have a negative there. Okay, in D, we have an asymptote. So we have a function like this with an asymptote at x is -3. And a root at x is -2. So the graph is looking like this. We do have another asymptote there. That's not relevant for us. So I said, on our sine diagram, right, we're going to draw, I'll have to draw the sine diagram here. On our sine diagram, we're going to draw the roots, definitely. So the root of this equation is where it crosses the x-axis. And it crosses the x-axis at x is -2. So that's the first important piece. But we also include asymptotes. Now the way we include asymptotes is a dotted line. All right? So we need to be able to distinguish between a root, where it crosses, and an asymptote, where it never touches. It doesn't exist. Okay? It's undefined at that point. And then we're just going, is it above or below? So what we can see is to the left of the asymptote, okay, that vertical asymptote, the whole function is negative. It's completely below the x-axis. So we have a negative there. In between the asymptote and the root, in between -3 and -2, the function is positive. Okay? And then after the root, okay, after 2, the function is below the x-axis. It is negative. Okay, on to E. and we have, it's going like this. How many do we have? 3. Asymptote, asymptote, asymptote. So we have an asymptote at -6, -2, +2, +6, and then we have roots at 0, -4, and +4. Okay, so if we're drawing the sign diagram, we need to display all of the asymptotes and all of the roots, all in order as well. So we have an asymptote at -6, we have a root at -4, we have an asymptote at -2, we have a root at 0, we have an asymptote at +2, we have a root at 4, and then we have an asymptote at 6. Okay, so I'm just plotting all of the information on the graph above directly on the axes for the sign diagram. All right, roots at -4, 0, and 4. Okay, -4, 0, and 4, they're our roots. Asymptotes at -6, -2, 2, and 6. All right, and now we're just going, where's it positive, where's it negative? So we can see it's above the x-axis between the asymptote and the root, and then it's below the x-axis, above the x-axis, below, and it's just alternating like that. That is our sign diagram. Okay, we won't draw them algebraically just yet. Let's get you guys to have a go at 3E question 1. Okay.